The mass percent composition can be obtained experimentally, like that first strontium oxide example, where we had a mass of strontium and it reacted and it formed strontium oxide, and we have the mass of the product, and we can just plug those two numbers in. We can also calculate the mass percent composition from the chemical formula. And it's the same idea. It's the mass of element X per mass of the whole compound. But now we don't actually have a particular sample. And so what we're doing is we're just deciding to use 1 mole. So we choose 1 mole of compound because it's easy. So we say, okay, well, what's the mass of 1 mole of this compound? Well, it's the molar mass. We learned how to calculate that. And then we calculate the mass of element X in 1 mole, and that's easy to calculate too. And so we can use the chemical formula and calculate the mass percent. So calculate the mass percent of fluorine in Freon 114, which has this formula, C2Cl4F2. Sometimes chlorine, especially in this font, kind of looks like carbon and iodine. But if that was carbon, it would be lumped in with this carbon. And so that wouldn't make any sense for this to be carbon. This is chlorine. So to do this, percent fluorine. So we want the percent of fluorine. We want grams of fluorine per grams of C2Cl4F2 times 100. And we're just going to choose 1 mole. So in 1 mole of this compound, what is the mass? How do we figure that out? That we calculate the molar mass for the compound, right? There's 2 carbons, 12.01 grams. There's 4 chlorines, 35.45 grams. These numbers are coming off the periodic table in my head, but they're this real close to the ones on the wall. 2 times 19. And we add those together. 2 times 12.01 plus 4 times 35.45 plus 2 times 19 equals 203.82 grams. That's grams of C2Cl4F2. This mass is what goes in the denominator. That's the mass of 1 mole of the compound. What mass of fluorine is in this? Two times 19 is this piece right here. That's the mass of fluorine. That part goes up here. So you might want to actually figure that out. That's 38.00 grams. And so we have the percent of fluorine is the mass of fluorine in 1 mole of the compound divided by the mass of 1 mole of the whole compound times 100 18.64. Percent fluorine. Any questions? Your book has a lot of these little sections that tie chemistry into everyday life, and I really hope that you'll read them because I think they'll help you to understand the value of learning chemistry. I'm not going to test you on them, and usually I don't really comment on them during lecture because I'm not going to test you on them, and I'd rather spend time explaining things than I'm going to test you on, right? So, here's a little bit about fluoridation of drinking water. Bottom line, a little bit is good, a lot is bad, and that's the case for everything, even water. So adults who drink between 1 and 2 liters of water a day at a level of 1 to 4 milligrams per day are going to get a beneficial amount of fluoride. If you hardly drink any water, then you're not going to get enough fluoride. If you drink way more water than that, maybe you'll get too much. I think you'd have a hard time drinking enough to have skeletal fluorosis. Fluoride is often added to water because if your water source does not naturally contain fluoride, they add it to help prevent cavities. So it's added as sodium fluoride. So we can make a problem out of this. Yeah, chemists can make a problem out of anything. What is the mass percent composition of fluoride in sodium fluoride? And after we answer that, how many grams of sodium fluoride should be added to 15 liters of water to fluoridate it at a level of 1 milligram of fluoride per liter? This is a practical calculation that if you're running the wastewater treatment plant, somebody has to figure this out. Well, the mass percent of fluorine in sodium fluoride. Let's see if we can knock this out. It's going to be the mass of fluorine in 1 mole of sodium fluoride, right? So sodium fluoride is going to be sodium plus fluorine. It's a real simple compound, just one of each, right? And the fluorine in there is just the 19. So I'm sort of showing the minimum amount of work here. So I've got 19, and then when I divide, I need to be careful and use parentheses. 22.99 plus 19, close the parentheses, equals times 100. And this is 45.25% fluorine. That means 45.25 grams of fluoride per 100 grams of sodium fluoride. Probably shouldn't have used white, it's all blending together. I didn't mean to do that. I just wanted to change the color. Is everybody with me on that? We're going to use, cross it out before we can use it. We're going to use this guy to help us with this problem. So here we've got some numbers. We've got 1,500 liters of water, and then we've got 1.0 milligrams of fluoride per liter. There's very little room at the bottom there, so I'm going to write this up at the top. 1,500 liters and 1.0 milligrams of fluoride per liter. One of those is a conversion factor, and one is just a regular old number, right? We want to start with the number. We're going to start with 15 liters. This is going to be a conversion factor. We'll also need this as a conversion factor. And what are we trying to find? Grams of sodium fluoride. So I'm going to make some space here because we need more room. So I'm just going to black this out. so that I can write in there, because I can. So our path, we need a path. We've got liters of water, and we want to end up with grams of sodium fluoride. Now we're going to use what we have here and figure out how we can get from one end to the other. Well, what about this guy that was given to us? This is milligrams of fluoride per liter of what? Liter of water, right? So using this factor, we could go from liters of water to milligrams of fluoride. Do we see anything else that has milligrams of fluoride in it? No. Like, I don't know what to do. Okay, let's start at the other end and work backwards. Here we've got grams of sodium fluoride. What about this guy? Does he have grams of sodium fluoride in it? Yeah, there it is. So this allows us to go grams of fluoride to grams of sodium fluoride. So working backwards, we do grams of fluoride. Could we get these two guys to meet? Can we convert from milligrams to grams? Well, if we can't, we should be able to. So there, we made the path. That's the hard part, figuring out the path. Once you've got the path, you just have to follow the path. So the path is liters to milligrams to grams fluoride to grams sodium fluoride. So liters of water, 1,500 liters of water. And the next one is milligrams of fluoride. And then we're going to go to grams of fluoride. And then we're going to go to grams of sodium fluoride. Just the units in the path. Liters, milligrams, grams of fluoride, grams of sodium fluoride. Same thing down here. I put the unit from the, and it disappeared. Come back. Okay, we found it. Let's try not to press that button again, whatever button that was. This unit goes in the denominator. Liters of H2O, those cancel out. We'll bring milligrams down here. Those guys cancel out. And grams of fluoride down here cancel out. Units. Units tell us what to do. Milligrams of fluoride per liter. That's this conversion factor that was given in the problem. 1.0 milligrams. So we've got 1.0 milligrams per liter. Does it bother you that there's no number down here? Anybody? Yes. It always bothers somebody. What could we do? What number could we put there? 1. If you need a number there, that is absolutely fine. Put the number 1. Okay? It's not going to change anything, except it might make you feel better, right? And so that's a good thing. Okay, this guy. Oh, we got to think about that. Let's skip that one for now. Let's go over to this guy. Here, that one's written out right here. 100 grams of sodium fluoride. So sodium fluoride's on the top, so 100 goes on the top. 45.25 goes on the bottom. Just this guy. Now we have to figure out this middle guy. What does milli mean? Milli equals 10 to the what? 10 to the minus 3. I have gram over gram. That's equal to 1, right? Anything over itself, divided by itself, is 1. So grams over grams, that's still 1. But I've got a milli on the bottom. I want to put what it means on the other side. going to put 10 to the minus 3 up here. Because 10 to the minus 3 is milli. That's what it means. This is a nickname for 10 to the minus 3. So 10 to the minus 3 grams equals 1 milligram. The problem is that people put the 10 to the minus 3 in the wrong place. And that's like telling me that 1 inch is 12 feet. Right? You know how big a foot is and how big an inch is, and so you recognize that as ridiculous. But you have no problem telling me that 1 gram is 10 to the minus 3rd milligrams, which is equally ridiculous. If you follow this pattern, know this pattern. The prefix on one side, the 10 to the whatever that it means on the other side, it'll always come out right. And when we look at this, you may wonder, well, how do I get that into my calculator? Well, if you multiply by 1, doesn't change anything, but now it looks like it's in scientific notation, because it is, and it'll work out. So then on your calculator, you've got 1,500 times 1 divided by 1 times 1 EE minus 3 divided by 1 times 100 divided by 45.25 equals, and how many significant figures should my answer have? 2. The numbers that they gave me had 2 sig figs. So this is 3.3 grams of sodium fluoride. Is how much sodium fluoride that would be added to 1,500 liters of water to get the appropriate amount of fluoride in it. Any questions?